Let's see if I can. Even though I have some graduate I have a graduate degree in artificial intelligence and in econometrics, I'm a bit of a Luddite, so hopefully I'll be able to get this to work. Actually, I was at a artificial intelligence conference back in '99, and Martin Minsky, who's one of the early guys in AI. And so imagine Martin's up here, and he's, he basically was one of the guys that starts AI. It's for an AI conference, so the entire room, there's probably twice this many people. They're all computer scientists. They're all in artificial intelligence. And the guy gets up there, and he cannot get his Mac to plug into his keynote presentation. And then you say it's almost like a Far Side situation where you've got like 500 computer scientists just shouting out, you have to take a look at the thing or that thing. And it took them literally 15 minutes. And it was, I was just looking around, it was one of the greatest moments I think, of my life. Second greatest moment. So I just found out that there's like people from like 24 countries here in Horseshoe Bay, Texas, which my brother lives in Austin, and I've been coming here since like '93. I never even heard of this place. So the fact that there's like people from like 23 different countries here is pretty awesome. So I would like to welcome you to America. So this is 62 inches. That's 5 feet. I don't know what it is in metric, and we're in America, so I don't really care. But this is one of the few, that's right, USA. USA. Could be worse, could be the British, could be the imperial system, that's even more confusing. But anyway, so this is the diameter of this pizza is 5 feet. And you can go to San Antonio and get this. And so the way I look at it, or my talk, and I think most of what we're here for, is this idea of matching customers to experiences, right? To have delightful experiences. This was one of the only times in my entire life that, because I knew I was going to go get big pizza, but I didn't know how big it was going to be. And it's one of the only times where like the fantasy, how big could this really be? It's not going to be that big. The reality blew away the fantasy. So this is definitely an experience that delighted the customer, and that's me. So what am I going to talk about? Oh, this is the small size, by the way. So that's because we're in Texas. Everything is big. So again, the main idea is we want to talk about how we're going to connect customers to experiences in some sort of optimal way. I know a lot of us look at it in slightly different ways. I'm gonna take kind of a data approach to it. It's going to be a little bit more campaign-like, as opposed to like this overarching idea of maximizing profit for your organization. This is really going to be a little bit more ticky-tacky. This might be the type of thing that some folks might have some complaints with, but that's fine. You guys can argue with me afterwards. I tend to need. I get confused really easily, and so I tend to need a framework for thinking about things and putting them together. And I find that it gets confusing when people are talking about A/B testing, and they're talking about targeting, they're talking about optimization, they're talking now about multi-arm bandits. And is multivariate testing better than targeting? And they start asking these questions that really belie a certain confusion. And what I found, at least for me, when I'm thinking about these problems, is that a decision rule, and I'll go into that in a little bit, is just a really nice way to kind of think about how data goes together and how we can link our customers to experiences. I'm going to very quickly talk about how we go about picking these rules, and I'm going to claim that's optimization. This is very related to the bandits. Actually, I pulled out a ton of stuff because I knew Lucas was going to talk about bandits, and he did a way better job. You'll see from my presentation that he did a way better job than I'm going to do. And then we'll talk very briefly about predictive models, when and where might you use them. And even if you're not going to use them, or it's not really currently in your domain to be doing it, I think as things unfold in time, these systems are really just going to be embedded in our environment, and I think it's good to know about them, and it's also good, so if like a vendor like myself comes over and starts trying to sell you something, you can have some good foundation to know whether they're BSing you or not. So decision rules, what are they? Super simple. This is going to seem trivial because it kind of is, but it's just, if this, then that, right? And that's all I'm really talking about right here. Is just this basic construct. And what it really is, it's going to be a logic, right? It's a logic that's going to link an observation to an action. And that's like kind of the whole point of it, is to really start focusing on actions as opposed to data. That's kind of one of my pet peeves, and I don't quite understand the fetishizing of data in of itself. It's really not particularly useful until it's actually deployed to make a decision to take some sort of action. And until you do that, even if it's stay the course, that's still a decision, that's fine. But data in of itself has really no value. It's just an artifact until it's deployed. So to make this more general, so if we see some sort of observed data, and that was talked about, I think the gentleman from PayPal was talking about observational data. So if we see something, and that's really just censoring, if we see something in the world, we see our observed data, then we're going to do something, we're going to take some action. And I want to make this distinction between observed data and causal data, right? And I think this is a key takeaway, if this isn't already obvious to you, and it may be, but really there's two types of data, and there's observational data, and that's basically web analytics data. This is everyone, the big data, whatever. This is that type of data. This is data that we've passively collected. We haven't done anything really except for put sensors into our system, be it a tag or whatnot. We're just collecting, and it's the easy stuff to do in a way. I mean, it's not easy, but it's relatively easy because we're not really doing anything. And then there's what the CRO, what you guys are doing in CRO, and that's really experimentation, and the whole point of that is that we're collecting a different type of data, and we're collecting data that in a sense is causal. So we're learning when we manipulate the system, when we have different experiences, we can see what the return is, and so we can estimate some sort of impact based upon that. And it's very important to have this distinction. There's a quote, I forget the guy's name, but there's no causation without manipulation. Right? There's some controversy around that, but essentially, unless you do something to the system, there's like some sort of difference, you can't really estimate a causal effect. Optimization, I would say it's about learning efficiency. There's this notion, Lucas just talked about it. I think I would have talked about it. Another way to look at it, I would say, is there's an opportunity cost to learn. That's really it. So there's some sort of cost that we're incurring by taking a longer time to learn, and then we want to apply these best rules. So if you have any questions about this afterwards, feel free to come up and spend as much time with this guy, and you can tell he loves answering questions, so he'll answer all of your questions. Don't come to me, because he did a great job. I was super impressed by that. So it's nice. Okay. So great, I can talk about generally optimization is picking rules quickly, but how are we going to do that? There's an infinite number of possible rules. We have all this data about the user and the context, and it's not really clear up front what the best way is. I actually like the hippo in certain use cases, I guess, or situations. Like if I'm in fashion, I would take one Anna Wintour over everybody, I think. Any data scientist or almost any amount of data, right? So there's definitely a place for the domain expert. There's definitely a place for someone who knows something. And in fact, there's this theme that comes in with data-informed learning, which is, oh, you're going to over-optimize, you're going to lose taste, you're going to lose quality, whatnot. And the reality is in no functioning or workable system can you possibly do any of this stuff without sort of prior information, without domain expertise. Which is why you have, not myself, but the other folks who are up here, they're kind of experts in the space, and they're helping you inform how to go about doing this. And of course, also by learning from data. So it's this interaction between the two. So learning by experimentation. So the A/B test, now that you know everything about multi-arm bandits, you can swap the idea of bandit for A/B test. And just to make it easier for when we talk about the more complicated stuff a little later on. I'm going to just represent A/B tests graphically. So we're going to start thinking in terms of like a little picture or a graph. So I know this is pretty obvious, but this is A/B testing, right? And so anybody comes in or everybody comes in, and then we're going to collect data on 2 different variants, or k number of variants, or if it's a multivariate test, whatever. But we're going to try out different experiences, and then we're going to estimate, and we're going to evaluate the marginal impact, right? This is where people start getting hung up about p-values and statistical significance and whatever. I'm definitely sort of in the Lucas school, and I don't really, there's actually, somewhat interestingly, there's a psych journal, Basic and Applied Psychology, that has just banned, this is a real proper research journal, banned the use of p-values and confidence intervals. In fact, most frequentist inferential statistics. You cannot use that to publish anymore. And there's actually a fairly large, I don't want to say controversy, but there's a discussion within the statistical community about the efficacy of just p-values in general. You definitely shouldn't be using them as a stopping rule. So anyway, but however you go about picking, banded or otherwise, or what have you, this is the rule, right? And it's a trivial rule, but here we see if anybody, so a wild card, if you're doing your regular expression, you put your star in there. I think it's a cleaning star. And then offer B, right? But is this enough? And obviously it's not going to be enough, because it's going to depend, right? And it's going to depend on your customers, right? And do they all respond the same way? Most use cases, probably they don't, right? And so segmentation, yes, right? This is always the answer for everything. Just go segment, and you'll unearth the answer, the optimal answer. So 2 types of people in the world, let's say hypothetically, keep it simple, right? There's the good folks of the state of Texas, and then whatever, there's everyone else, right? So we're gonna run a test, and the thing that's just to keep in mind is that we're really kind of have a hard partition in the segmented test, right? So you're either from Texas, which you can guess whether I'm from Texas or not, or you're not from Texas, and those 2 are going to be 2 separate learning pools, right? So I'm going to run 2 disjoint tests. These are rival, these are mutually exclusive segments. And that tends to be how people think about segmentation. It's kind of these mutually exclusive buckets. And we'll see that actually, we want to expand our idea of what a segment's going to be. But we're just going to collect the data just as we did before. And it turns out that the folks in Texas like option A, and everyone else is contrarian to the Texans, and they like option B. Maybe this is like burritos, right? Texas burrito, there's no rice. Rice is like an abomination, right? Anyone from Texas? I think rice and burrito is like totally not kosher. But in California, you have rice, so maybe that next time it'll be rice and burritos. So the rules, so we have targeting rules now, right? So implicitly, and this is like what Lucas was talking about, we only have the fixed rule. So if you're Texas, no rice in your burrito, and if you're not from Texas, rice in your burrito. But is that going to be enough? I would say in certain use cases, it isn't, right? So why isn't it going to be enough? Let's say we had just 35 attributes about our users, right? So maybe they come from Facebook, certain geo, whatever. Anyone have any suggestions or ideas of like how many combinations we got there? It's a lot. So just to go old school, nerdy, geeky, I don't know if I'm going to be dating myself, but it's billions and billions of combinations, right? So, and I guess that's known as a Sagan, right? So if you have billions and billions, it's a Sagan. So, but that's just 35 bits of data. You have up to whatever that number is, right? So it's not going to scale, and there's going to be no way that you're going to run 35 trillion tests at once. So we're going to have some sort of way of learning over all of these possible combinations. So what are we going to do? Well, this is where predictive modeling can come in if it's appropriate. And this is really going to be more applicable if you have sort of like a high transaction system. I'm going to talk a little bit about a lottery that we're working with. It doesn't need to be a website, so all these ideas doesn't just have to be presentation layer about your website. It could be about a call center. It could be about the back of the seat in the airplane or whatever. Any sort of transactional event, we can apply this type of logic to. So how we're going to be more efficient is that we're going to use a model, and the model, we're just going to run one experiment conceptually, but we're going to like blend all of the features together, right? And that's really what the model is going to do. So we're going to be making some simplifying assumptions, and we're just going to like shove everything in there. So maybe we don't just have Texas, not Texas. Maybe they're mobile, not mobile, whatever, weekend, weekday, right? And we're just going to shove them all in. And what the model is going to do is that it's going to give us an estimate of the preference that each one of those features expresses, the preference as well as the intensity. So there's really behind the scene, there's going to be a number, but conceptually you can just think each one of these features is going to have a vote or a certain number of votes on what it's going to prefer. So like the Texas really is psyched about A, which is no rice in the burrito, and maybe mobile really likes rice in the burrito. The weekend, whatever, doesn't care. And that's the other thing. So a lot of the features may not be informative between one or the other, right? So what are we going to do? Well, we have to have some methods for learning. I'm not going to go into talking about this in this talk, but I'm going to be here. So if anyone is interested in learning more about some of these methods, pretty standard. They're all pretty much basically regression type models. There's a lot of hype right now about deep learning. You can just really think of that as sort of like a nested or a hierarchical set of regression models. That's very powerful, but there's actually a lot of it is hype. Not surprising. It's kind of like big data. But I did actually I spent a vacation in France, right? Very romantic, at machine learning summer school, not so romantic. And actually was called a nerd by the other classmates there, which was I thought was pretty awesome. And but what was actually thrilling for me was this guy, Yann LeCun, actually was speaking there. This is back in 2008, so it was before like the hype around deep learning, and so you could just have a drink with him and talk about convolutional nets and whatnot. But anyway, happy to talk about this, but there are procedures. This is the world of predictive analytics and machine learning. That's kind of how this gets linked in to the whole thing. So we have our model, we're going to collect data, and then we're not going to use it, right? So we've run it, we've built the model, and so we have the numerical scores. And so let's say we know a user comes in and what's active is Texas and mobile. And remember, they were conflicting with each other, right? So Texas really preferred A, rice, no rice, and mobile preferred B, which was with rice. And so remember, they're voting conceptually for which one to pick, just like when you go out to a restaurant and there's a group of you, and that's always a nightmare because like, no one wants to say what they want to go to, and you're all trying to like pick which one, and there's really no optimal answer often. But you're all going to vote, but the person is really kind of pushy, as like, no, we got to go to this place. Often you wind up going there. So just think model is the same thing as just a group of you going to a restaurant, and you're all arguing which one to go to. And so ultimately, the one with the highest score is going to win, right? So it's kind of like A/B test, but a little bit more advanced, but you can think of it kind of the same way. And so we now have a targeting rule, right? And that was induced now, but if you think about it, there's all possible combinations here. And so just this one model generates, all the possible combinations of decision rules that we could possibly want, right? So if Texas and mobile, then it's A. So here's an actual case study that my company is doing with a lottery or a company, and they're online, and they said, hey, I wonder if we currently suggest like a $2 ticket, right? So you can get 2 draws from the lottery, which happens like one night a week. And they said, I wonder if we raise it to 10, I wonder if we'll get more money that way. And then they said, actually, also, I wonder if that's going to depend on different types of users. So let's have it predict which users or which customers are more likely to be responsive to the 2 bid and which are going to be more responsive to the 10 bid. So that's what we did. And so they had like age, gender, day, past play of the games, and we fed that into the system. And this is all online, so it's like their system is talking to us, and it looks like this. And this is how we communicate back, so we can communicate server to server. It doesn't have to be in the client. It doesn't have to be just manipulating the DOM as we tend to think about it. And so we just respond back and we say, hey, for this particular user, do the $10 bid. And then, and this is the user, for a user with these active features. So if they have these features, then play this, right? And then that gets resolved in their internal systems. And so they can go in the reporting. This looks kind of crap. Sorry about that. I had to like block out some of the things. But essentially, you can go in the reporting and then construct all the different possible decision rules based upon the combinations that we've seen up until that time. So you can say, if the person comes in on a Monday at this time of day and they're not logged in, then we're going to predict that 10 is the best answer, right? So this is that same structure. If we see these conditions, then we take an action. And then we can also look at the predicted value, right? So this is kind of the sum votes for the $10 bid versus the $2 bid. And you can see what the predicted value is, an expectation, right? So you kind of see how predictive modeling is blended in with A/B testing here. But how are we going to evaluate it, right? So when we're doing a test, it's pretty simple. We've got to normally have some sort of control, and we're going to take a look at the different options. But what we're going to really need is a baseline here, right? So we need a baseline, and we use this idea of the principle of indifference, and the principle of indifference is also known as oh shoot, I forget, it's mathematician. It's basically, this is used in Bayesian analysis, and it's really just saying, if we don't have any prior knowledge, let's say you're starting a new problem, right? So you don't have a control, really. In the face of not having any prior knowledge about what's better than any other, then the optimal policy is just to randomly play them, right? And this is, actually this is where average is good. Right, playing the average. It's like a hedge, right? It's just like you're buying a mutual fund. You're actually buying a share of all the possible options. So this is what we're going to use as a baseline. This is often used as a baseline for modeling because think about the model, there's like thousands or hundreds of thousands of possible rules and whatnot, and we're going to want to think of it as just one big decision, right? And so what's good about it is that it's a baseline you can always use, right? So even in cases where we have a new product and we're trying to think about what 4 options are, and we have no reason to believe one is better than the other. So there's a situation where you can just use the random play, the average. And then also it's good for, if you think about we have a model, and let's say the model looks like it's doing better than a fixed control that you had. So let's say $2 was the control, and the model's doing better. But it could be that the model is just picking randomly. Right? The model hasn't learned anything. The model is just like randomly playing. And it's still doing better than the control because some of the other options are better than the fixed control. So that would be a case where the model is really not informative at all. And you wouldn't know it if you were just using a fixed control. So graphically, it just looks like this. So you can think of it being partitioned into 3 buckets. So your users come in, they get either assigned to like the fixed control if you have one, they either get assigned into the random group, and this is kind of similar to what Lucas was talking about if you're doing epsilon greedy, where a certain percentage get a random play, and that's this little bucket, and so it has the advantage of also being a good control. And then the rest get thrown into the model, and the model is making the selections. And so then what we do is we do the same thing as it's like a meta A/B test, right? And what we're really doing is testing the efficacy of the model, and then we just compare the model result by the random, divided by the random, and that's your lift, right? And that's like the marginal return of the model, and that's like the marginal return conceptually of all that targeting data, right? And so people, in the industry or in the media, they start talking about the value of data and how it's like gold and whatnot. But until you do this calculation, and this calculation is telling you what the marginal value of that additional data is. Because if I had no data, I could just do random. So it's the lift over this, right? And I think this is a key takeaway. I know maybe it looks kind of complicated or not, but it's really about the value of complexity, right? So we're going to do something, because remember, targeting is doing segmented targets, or you're doing something more advanced. It's making your system more complex, right? As opposed to your system or your website just doing one thing, right? And that's simple. Now you're saying there's all this forks. So if the user is coming from Texas, then they do this. If the user is coming in from whatever, then they do this, whatever. That's a much more complex system that you have to manage. And this is telling you what the value of that complexity is, right? And it may be 0, right? So you have, it's like parsimony. It's like, I'm going to trade off complexity for additional returns. So summarizing, it's super simple, right? There's 5. We need to have measurable goals, right? So there's something that we want to achieve, something transactional. Got to sense the environment, right? This is web analytics, right? 101, whatever, right? We're just capturing stuff, not doing anything, really. That guy's doing a little something, I guess, but whatever. You got to be able to act and execute, right? You have to be able to do something. Even you can collect all the data you want. Like, oh, it's awesome. Look at my Google Analytics reports. It's so advanced and whatever. But if your site or your call center or whatever is set up that you can't make any changes to it, it's completely useless. So you got to be able to execute or experiment. You got to be able to observe the outcomes. So you have to have transactional goals and events to achieve. I'd give that little guy a bone too, because that's pretty cute, right? But I'm a bad disciplinarian. And then you're going to learn the logic. And so if you sense the environment, you collect your data, then you take a certain action, and then you're going to receive some sort of reward or objective. And this is it. This is machine learning 101, actually. And that's the story. Sticking with it.